Automated analyzer, Wikipedia article audio. An automated analyzer is a medical laboratory instrument designed to measure different chemicals and other characteristics in a number of biological samples quickly, with minimal human assistance. These measured properties of blood and other fluids may be useful in the diagnosis of disease. Routine biochemistry analyzers. Immuno-based analyzers. Many methods of introducing samples into the analyzer have been invented. This can involve placing test tubes of sample into racks, which can be moved along a track, or inserting tubes into circular carousels that rotate to make the sample available. Some analyzers require samples to be transferred to sample cups. However, the effort to protect the health and safety of laboratory staff has prompted many manufacturers to develop analyzers that feature closed-tube sampling, preventing workers from direct exposure to samples. Samples can be processed singly, in batches, or continuously. The automation of laboratory testing does not remove the need for human expertise, but it does ease concerns about error reduction, staffing concerns, and safety. These are machines that process a large portion of the samples going into a hospital or private medical laboratory. Automation of the testing process has reduced testing time for many analytes from days to minutes. The history of discrete sample analysis for the clinical laboratory began with the introduction of the robot chemist invented by Hans Baruch and introduced commercially in 1959. Autoanalyzer is an automated analyzer using a special flow technique named continuous flow analysis, invented in 1957 by Leonard Skeggs, Ph.D., and first made by the Technican Corporation. The first applications were for clinical analysis. The autoanalyzer profoundly changed the character of the chemical testing laboratory by allowing significant increases in the numbers of samples that could be processed. The design based on separating a continuously flowing stream with air bubbles largely reduced slow, clumsy, and error-prone manual methods of analysis. Hematology analyzers. The types of tests required include enzyme levels, ion levels. Simple ions are often measured with ion-selective electrodes, which let one type of ion through, and measure voltage differences. Enzymes may be measured by the rate they change one colored substance to another. In these tests, the results for enzymes are given as an activity, not as a concentration of the enzyme. Other tests use colorimetric changes to determine the concentration of the chemical in question. Turbidity may also be measured. Cell counters. Antibodies are used by some analyzers to detect many substances by immunoassay and other reactions that employ the use of antibody-antigen reactions. When concentration of these compounds is too low to cause a measurable increase in turbidity when bound to antibody, more specialized methods must be used. Recent developments include automation for the immunohematology lab, also known as transfusion medicine. Coagulometers. These are used to perform complete blood counts, erythrocyte sedimentation rates, or coagulation tests. Other hematology apparatus. Automated cell counters sample the blood, and quantify, classify, and describe cell populations using both electrical and optical techniques. Electrical analysis involves passing a dilute solution of the blood through an aperture across which an electrical current is flowing. The passage of cells through the current changes the impedance between the terminals. A lytic reagent is added to the blood solution to selectively lyse the red cells, leaving only white cells, and platelets intact. Then the solution is passed through a second detector. This allows the counts of RBCs, WBCs, and platelets to be obtained. The platelet count is easily separated from the WBC count by the smaller impedance spikes they produce in the detector due to their lower cell volumes. Miscellaneous analyzers. Optical detection may be utilized to gain a differential count of the populations of white cell types. A dilute suspension of cells is passed through a flow cell, which passes cells one at a time through a capillary tube past a laser beam. The reflectance, transmission, and scattering of light from each cell is analyzed by sophisticated software, giving a numerical representation of the likely overall distribution of cell populations. Some of the latest hematology instruments may report cell population data that consist in leukocyte morphological information that may be used for flagging cell abnormalities that trigger the suspect of some diseases. Reticulocyte counts can now be performed by many analyzers, giving an alternative to time-consuming manual counts. Many automated reticulocyte counts, like their manual counterparts, employ the use of a supravital dye such as new methylene blue to stain the red cells containing reticulin prior to counting. Some analyzers have a modular slide maker which is able to both produce a blood film of consistent quality and stain the film, which is then reviewed by a medical laboratory professional. Automated coagulation machines or coagulometers measure the ability of blood to clot by performing any of several types of tests including partial thromboplastin times, prothrombin times, lupus anticoagulant screens, D-dimer assays, and factor assays. Coagulometers require blood samples that have been drawn in tubes containing sodium citrate as an anticoagulant. These are used because the mechanism behind the anticoagulant effect of sodium citrate is reversible. Depending on the test, different substances can be added to the blood plasma to trigger a clotting reaction. The progress of clotting may be monitored optically by measuring the absorbance of a particular wavelength of light by the sample and how it changes over time. Automatic erythrocyte sedimentation rate readers, while not strictly analyzers, do preferably have to comply to the 2011 published CLSI procedures for the erythrocyte sedimentation rate test, H02A5, and to the ICSH published ICSH review of the measurement of the erythrocyte sedimentation rate, both indicating the only reference method, being Westergren, explicitly indicating the use of diluted blood, in 200 mm pipettes, bore 2.55 mm. After 30 or 60 minutes being in a vertical position, with no drafts and vibration or direct sunlight allowed, an optical reader determines how far the red cells have fallen by detecting the level. Some tests and test categories are unique in their mechanism or scope, and require a separate analyzer for only a few tests, or even for only one test. Other tests are esoteric in nature. They are performed less frequently than other tests, and are generally more expensive and time-consuming to perform. Even so, the current shortage of qualified clinical laboratory professionals has spurred manufacturers to develop automated systems for even these rarely performed tests. Notes: analyzers that fall into this category include instruments that perform 1. Rosenfeld, Louis. 4 Centuries of Clinical Chemistry. Gordon and Breach Science Publishers, 1999. ISBN 90-5699-645-2. pp. 494-92. DNA labeling and detection, osmolarity and osmolality measurement, measurement of glycosylated hemoglobin, and aliquoting and routing of samples throughout the laboratory.